Hey, thanks for listening to 11.3 Geometric Sequences and Series. So today we're specifically talking about the type of sequence where you multiply to get the next term. So a geometric sequence, the next term is found by multiplying. And again today there are going to be two different types of formulas. We're going to have a general rule. We're also going to find the sum. So there's two main formulas, and we're going to do a lot of different things with the same formulas. So make sure you watch at least one of each type of example. So don't stop the video after example 3. Make sure you watch all the way until the end so that you understand everything. Alright, so a geometric sequence. The next term is found by multiplying. You can have it multiplied by a fraction. So instead of saying that we're dividing, every single time we're going to say it's being multiplied by something, even if it's by a decimal or a fraction. Can be multiplied by a fraction. And the thing that you multiply each time to get the next term is called the common ratio, which we denote by r. So we're going to use the variable r. Just to start off with today, example 1, we're going to determine if each thing is geometric, arithmetic, or neither. So first of all, arithmetic, remember from last time, we're adding or subtracting to get the next term. For geometric, we're testing to see if I can multiply to get the next term. Some of them are kind of obvious. If you look at A, it immediately looks like it's subtracting 2 each time. So that one's arithmetic. And it has a D because it's arithmetic. The common difference is -2 because I'm subtracting. This next one, first maybe I'm going to test arithmetic each time. Okay, you know what? This one is +4 every time. So this one is also arithmetic. And D is 4. Let's look at example 3. Or example C, I guess I should say. Alright, I made some boring examples because that one is also arithmetic. Woo! Alright, arithmetic, D is 3. Now look at the next one. If you test arithmetic, immediately it stops working because the first time it'd be +5, the second time +10. So that's how you can say, oh, it's not arithmetic. So now I'm going to test geometric. To go from 5 to 10, it's ×2. Does ×2 work for each one of the differences? It does. So it's geometric, and because it's being multiplied by 2 each time, we would say R is 2. Now sometimes it's a little tricky to see if it's geometric. For this next one, for example, if it was going to be arithmetic, it would be subtract 40 each time. That's not going to work. So I need to figure out if it was geometric, what's happening between 160 and 120. And to figure that out, we can always just do a term divided by the previous term. So to go from 160 to 120, it's kind of like we're working backwards. That was actually then multiplied by 0.75. And then again, previous term or next term divided by previous term to test what's happening, what the R is. And actually, it ends up being every single time it's being multiplied by 0.75. Notice again, I do not say it's being divided. I say multiply by a decimal. So this one is geometric, and the R is 0.75. All right, let's look at F. Now, this one, if I do term divided by previous term, 16 divided by -32, that is -1/2. And if I test it, this one I can kind of eyeball. It looks like every single time it is being times by -1/2. So it is geometric, and my R is -1/2. Alright, so arithmetic, we're trying to find add and subtract. Geometric, we're trying to multiply. And geometric is what we're going to focus on for the rest of the lesson. Here's the formulas you need to know. There is again a rule for the nth term. And again, that's just a fancy way of saying our formula. So a rule for the nth term this time is a sub n equals a sub 1 times r to the n minus 1 power. Just like last time, a1 is the first term. This time R is that common ratio I was talking about. And then AN is term N, and N is whatever term I plug in for AN. Now, sometimes it can be kind of tricky to find R. So you know how I was saying a little bit, just kind of briefly, you divide to figure it out? Because if I'm multiplying to get the next term, the opposite of that would be to divide, work backwards to figure out what just happened. We won't always have each term right next to each other though, so here's what we can do. I'm going to do term M divided by term N, and again, term M comes later in the sequence. So term N comes first in the sequence, term M comes later in the sequence. Once I find that fraction, I take the M minus N root. So M minus N for the root number. So remember, back from chapter 7, we might need to cube root, fourth root, square root, fifth root. So there's all sorts of different roots we can find. And then we'll put in this same box the geometric series or sum formula that we will be using later on in this lesson. So here it is, S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Alright, so let's just practice finding the common ratio for a little bit. My dog is being really whiny. Let's see if you can hear her whine. Are you whining, Bailey? Okay, she's being microphone shy right now. So here's what we're going to do to find the common ratio. And let me just say, if I was going to use the formula in this case, let's say I was going to use the first term and the second term, for my ratio then, or my formula I guess, I'd have 2 minus 1 for the M minus N, and then term M is negative 32, term N is 64, but 2 minus 1 is 1, and I can't really take the 1th root of something, so in this situation it ends up just being negative 32 divided by 64, so negative 1/2. Alright, and then for this one again, take a term divided by the previous term, and you end up with your R. This time R is 3. Alright, so now let's get into the meat and potatoes of the lesson, which is finding a rule for the nth term. So just like we did in section 11-2, only a lot of students like this better with the geometric because it's a little faster. Once I plug my numbers into my formula, I don't really have to do anything else. And just so you know, if I'm going to write a formula rule this time, I want to fill in term 1 and N. So every single time I need to find term 1 and R. Sorry, I just said N. I meant to say R. I want to find term 1 and R and plug that into the formula. Finding term 1 and R is going to be slightly different every time. To start off with, it's easy. I obviously can see term 1 just by looking at the formula. And I can find R by doing a term divided by its previous term. So for example, negative 12 divided by negative 8. And because those two terms are right next to each other in the sequence, like I was showing in example 2, I don't actually end up really having to square root anything. And then I am going to plug those in. So term 1 is negative 8. And R is 3/2. The thing is, there's nothing I can simplify, so once I plug them in, I'm done. That's why students like this better than arithmetic sometimes, because it's faster. Alright, this particular example also asked me to find term 8. Now, when I find a specific term, if this is going to be term 8, that means that right in for N here, I put a 8. And notice now, think order of operations, powers come before I multiply. So I could either just type this all into my calculator, or if I was going to type it in one at a time, I got to do 3/2 to the 7th power first, then multiply by negative 8 since powers come first. So term 8 ends up being negative 136.6875. please pause the video and see if you can do part B on your own right now. So identify what A1 is, identify what R is, and then plug them into the formula, then see if you can find term 14. Pause the video, try it, and when you unpause, I'll have the answer showing. All right, there's our answer for part B. And comment, you may have gotten this answer and thought you were incorrect because it was such a big number, but just if you think about it, when I multiply numbers, multiplying makes something get big fast. For example, if I add 2, add 2, add 2, add 2, that goes much slower, or my number increases much slower than if I go times 2, times 2, times 2, times 2. It increases much faster. So you will get big numbers when you're finding your sums today. All right. Now I want to show you what to do if you do not know what R is. So go ahead and listen in for part C here. Now I'm just given 2 terms. And remember, in order to write my rule for the nth term, aka write my formula, I need to know term 1 and I need to know R. I already know term 1. I am going to use this formula I told you about earlier in order to find R. And remember, A sub m always is the one that comes later in the sequence. Okay, so the actual numbers go inside and the term number goes outside. So if I'm going to fill in this formula, m is 8, n is 1, and then I fill my actual terms in here. So what I'm going to do in my calculator is the 7th root of negative 81,920 divided by negative 5. So let's quickly remember how to type this into my calculator. So if you have a calculator kind of like mine, I'm going to have to type the root number first. So I type in 7, and then I'm going to hit the math button, and it's the 5th selection actually that lets you select any root. And it looks like 7 times the square root, but it's not. The 7 replaces the x, so it becomes the 7th root of, and then in my calculator, because it doesn't give me a parentheses, I have to add a parentheses there. Some of yours might actually do it automatically. So that's how I would type it in, and I end up with 4. So R is 4. Once I have my R, now I'm going to write my rule for the nth term, aka write my formula. So to write my formula, all I do is plug in A1 and plug in R. Again, I do not have to rearrange it. That is it. So that is my formula. And then my typing got a little funky here, but it says find term 10 is the second step. So find term 10. So term 10 is negative 5 times 4 to the 10 minus 1 power. So negative 5 times 4 to the 10 minus 1 power, so negative 5 times 4 to the 9th. So I end up with, by the way, I think my calculator, I need to put parentheses around this. Sorry, I'm going slow. Okay, there we go. So negative 1,310,000